Hello everyone, welcome back to ptet.chemistry channel. So this is the start of section 10.4 on this topical MCQ. This will be on alcohols. It's just my classification, 10.4. So here they want you to indicate which one is a primary, secondary and tertiary. You will have seen me using this in my other tutorial video where I use this 1 degree to show it's a primary, secondary and tertiary alcohol. Okay, although in Word you should have written down primary, secondary and tertiary. Okay, so to identify primary alcohol, the carbon with the OH is bonded to one other carbon. The carbon with the OH is bonded to two other carbon. The carbon with the OH is bonded to three other carbon. Alright? The carbon with the OH here is bonded to one other carbon. So this is primary alcohol. The carbon with the OH here is bonded to the carbon with this OH is bonded to one other carbon. This is primary alcohol, but there's another OH here. The carbon with the OH here is bonded to two other carbon. So this one is a secondary alcohol. Okay, so that is also correct because there is a secondary alcohol, alright? Here, this one is a primary, this one is a primary, this one is a secondary. For the same reason that I've just outlined before, this carbon with the OH is bonded to one other carbon, same as this. This carbon with the OH is bonded to one and two other carbon, secondary alcohol. Alright, so it's not a tertiary alcohol, so A cannot be the response. For B, I'm gonna go straight to this, where this is the OH. The carbon with the OH is bonded to one other carbon. This is primary alcohol, so that one cannot be, yeah? This one is a tertiary alcohol, because the carbon with the OH is bonded to one, two, and three other carbon. It's not a secondary alcohol, alright? Whereas there was secondary alcohol in this second column here. This one is a primary alcohol. I hope you can do the exercise on your own now. So B cannot be the answer here, even though this is correct for being primary. This next one, the carbon with the OH is bonded to one other carbon. That is primary alcohol. These both are primary and primary alcohol. When you are here, look at the carbon with this OH is bonded to one other carbon. When you are here, look at this carbon bonded to this OH is bonded to one other carbon. So that is a primary and primary. It's not secondary. I don't need to check that one. But for the sake of it, I can check all of them. There is primary and primary and primary. So the answer must be D. Let's go through D then. The carbon with the OH is bonded to one other carbon. That is a primary alcohol. The carbon with the OH here, the carbon with this OH is bonded to two other carbon. This is a secondary alcohol. The carbon with the OH here is bonded to three other carbon. This is a tertiary alcohol, just as required. Alright? Moving on to the next question. So, what can we say? So this compound R is neutral in this sense that the pH is pH 7. We have a carboxylic acid here, which is acidic, so I can cross out D. You give an orange PPT with 2,4-D and pH. This is short form 2,4-D and pH. In hindsight, this question is probably best after you have done carbonyl compound, which is a later section, like 10.6 in my category. I should have just left it in there instead of putting it in here. But anyway, there are bits and pieces in here that are related to alcohol. So this formation of orange PPT with 2,4-D and pH is actually a condensation reaction. So you can find that out when you reach the carbonyl compound chemistry. It evolved HCl when you treat it with PCl5 in the cold. You don't even need heating or reflux because this is very reactive. Okay, and the reaction is very exothermic as well. So imagine if you heat it, it's going to be even more exothermic. Yeah, okay. So you don't want the reaction to be so fast they release so much HCl and become very dangerous. So you can just do it at room temperature with PCl5. It turns the ROH into RCl. It also turns, by the way, the carboxylic acid into this thing called acyl chloride. And acyl chloride is something you will do in A2 chemistry. Okay. Anyway, we already established it cannot be carboxylic acid based on the first information. The last bit of information tells you whether it's this reaction or this reaction. I hope you can see that it is the hydroxyl. I'm not talking about alcohol. I'm talking about the hydroxyl OH bond. So you need an OH. This one has no OH. Therefore, it will give you negative result. It won't give you HCl when you treat it with PCl5. Then your response must be C. The next question, it says that it can decolorize dilute acidified KMnO4. You need the acid for the redox reaction to work. Hope you know it from your mini titration that you have done on this purple colored manganese 7+, okay? It will not decolorize bromine water, will not. So you have no unsaturation. Because if you have unsaturation, well, I suppose you can also talk about no alkyne as well. So basically, we are looking at saturated compound where everything we have is just carbon-carbon single. You cannot do addition. Ethene you can cross out. Decolorized acidified KMnO4, that is an oxidizing agent. Okay, so ethanoic acid cannot be oxidized further because when you look at the carbon with the carbonyl, that carbon has no more hydrogen. It's already oxygen. There's no more hydrogen here. If you cannot lose the hydrogen on the carbon, you cannot oxidize it further. So it cannot be ethanoic acid. Okay, and the thing in butane, just same like this, the oxidizing agent does not oxidize the CH bond. Okay, no effect on CH bond. So it does not oxidize butane. It does not oxidize the CH3 of the ethanoic acid. Ethanol can be oxidized further, as you will find out in section 10.5. And also, you have already learned in O-level that you can oxidize alcohol with acidified KMnO4. So that was from O-level GCSE knowledge as well, yeah? Which you will revisit in very soon in the next subtopic on alcohol, depending on how your school does it, yeah? So this is a multi-step reaction. So this is what we normally use as an oxidizing agent instead of Mn+7. Because Mn+7 is a more is a much stronger oxidizing agent. This is chromium +6. It exists as a dichromate anion. This is the orange color solution. It is an oxidizing agent as well. And you see this product has only one oxygen. So you see me covering this under under halogenal alkane chemistry perhaps. It's just that some of these questions overlap, so I might be doing them twice, or maybe even 3 times if they have been repeated over 3 different sections. So it's quite hard to classify them under specific topic, yeah? So as you could see in AS chemistry, a lot of the organic chemistry is not just individual topics, but they overlap with one another, okay? If they only have one oxygen, when you oxidize with this oxidizing agent, it cannot be carboxylic acid because carboxylic acid is minimum 2 oxygen. If you cannot be carboxylic acid, that means this is an oxidized product. As you could see, you have lost hydrogen. 10 hydrogen become 8 hydrogen. Alright, so this is definitely redox. So therefore, it tells you C4H8O must be either aldehyde or ketone. It must be either of these. Alright. What else can you say? It reacts with NaOH to give you this product. So this is actually, as you could see, you have plus OH and you minus Br. So that is your hydrolysis reaction. That is from something you will learn more under 10.5, which is halogenal alkane. I stand corrected in the previous section. 10.5 should have been on halogenal alkane. This is a topic on alcohol, which is 10.4. Okay, so 10.5 is now halogenal alkane. Anyway, what was I gonna do? Okay, let's think about 4 carbon. So aldehyde and ketones are structural isomer, right? They are functional group isomer. So it's hard to tell whether this is aldehyde or ketone. But I hope you can appreciate one information here. Not distill. If you want to get the aldehyde, you have to distill immediately. Therefore, you can cross out the aldehyde, it must be ketone. If you want the ketone, you just heat or reflux. But if you want the aldehyde, you need to heat and distill immediately. Otherwise, the aldehyde will be further oxidized to carboxylic acid, which then you will have 2 oxygen. So if you have a ketone, so therefore, C4H10O must be secondary alcohol. the carbon with the OH is bonded to 2 other carbon, it can only be this. Cannot have any other choice, because this one will give you 1, 2, 3, 4. That is butane 2O. If you put the OH there, you still want the lowest number. Whereas if you think about the other one is 1, 2, 3, 4, you don't go for butane 3-ol, because 3 is bigger than 2. So this is the correct one. Okay, so in fact this and this are the same. It will be both butane 2-ol. If that is your alcohol, that means hydrolysis. Then what is X? X is just, previously we mentioned about hydrolysis where we substitute out the Br to become OH. So there must be Br. And from that argument, this must be 2-bromobutane, 4 carbon, butane, position 2, 2-bromo. Okay, so next question is the last question on this 5-question series on section 10.4, which is on alcohols. So sodium reacts with 1 mole of compound Y to produce 1 mole of H2. If you are not aware of it, you can have 1 OH. When you react it with sodium, you do not get 1 mole of H2. This is a redox reaction. You will get a salt and then you will get H2. But your equation is not balanced. You only kick out 1 hydrogen atom, so there is half mole of hydrogen gas. All sodium salts are soluble. Well, soluble in this sense in the alcohol. Okay, suppose there's no point of me writing out this stat symbol, because you're not supposed to have water, so there's not supposed to be aqueous. Okay, alcohol is not water. But my point is 1 hydroxyl give you 0.5 mole of H2. But you also need to consider that carboxylic acid also has that thing called hydroxyl. So hydroxyl is the OH group. We are not talking about functional group here. Instead of this thing we call alkoxide, here you can get something called carboxylate. Okay, so it will be O minus Na plus. This will become very important once you go to carboxylic acid topic. Again, one of the OH will give you 0.5 mole of H2. So 1 OH, 1 hydroxyl give you 0.5 mole of H2. You want 1 mole of H2. I hope that convinced you. Therefore, 2 times hydroxyl OH. Could be 2 carboxylic acid, could be 2 alcohol, could be 1 alcohol, 1 carboxylic acid, does not matter. Okay, only 1 OH, only 1 OH, only 1 OH. OH of alcohol, OH of carboxylic acid. D must be the correct option. Okay, this is about balancing the equation. Some people just think that, well, straight away they think about acid. Acid reacts with metal, but metal also reacts with hydroxyl group alcohol as well. Yeah, part of the case study for alcohol. So this is it, the end of this short tutorial video. So please subscribe to the channel if you haven't. Please share the channel with your friends, your colleagues, your students if you find this useful, because MCQs are pretty useful to revise your AS concept. Okay, yeah, I'll see you in the next video. Thank you for watching.